Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 29, we will continue with composting. This is composting part 2. The different concepts that we will cover is municipal solid waste composting, composition of the feedstock or the incoming organic matter that comes for composting, scale of composting, bin composting, box composting, centralized large scale composting. We will do a case study of Mysore City Corporation, which uses both centralized as well as decentralized composting, and finally we will talk about compost quality. So MS, the municipal solid waste composting started in India during the 1970s, and initially a lot of mechanical compost plants came up. So we have earlier talked about mechanization, right? Mechanical and manual operations. So in mechanical compost plants, in the initial days this was set up. This had got a lot of processes, mechanical processes, and because there were a lot of machines and all, there were a lot of maintenance issues. Most of the equipment was also imported and all. So this has got a lot of maintenance issues. And because the garbage was mixed garbage, there was no segregation at the beginning. So that's why this kind of plants were introduced, but our garbage was so mixed, or the quality of the garbage was such, and the final resulting compost quality was pretty poor, and because of high mechanization, the prices were also very high for this kind of plants, and that actually resulted in failure of this kind of plants. So in the next, generation of compost plants started coming during the 1990s. And usually the private sector started working on this particular sector. That means there were a lot of operations set up by private entities. And here the mechanization was removed at the pre-processing stages. That means initial sorting was done manually to a certain extent, but already the waste was segregated, but still some amount of manual sorting was required because not everybody segregates perfectly. Or sometimes some areas of the city, don't segregate and they give mixed sort of waste, right? So that means some amount of sorting is required. But the mechanization of that particular process was eliminated, and mechanization was only adopted in the post-screening stage. That means one compost is produced, it's cured, or maybe in between, mechanization was introduced so that we can clean the final compost, and using trommels with finer screens. In the pre-processing, trommels of larger screens are used, but in the post-processing, trommels of finer screens, or air density separators, which removes the stones. Pieces of glass, plastic, grit, coarse sand, etc. can be removed from the final compost. So that means this is not removed at the beginning, it is removed at the end once compost is formed. This improves the commercial viability of the compost, improves the quality of the compost, and so on. And this kind of compost was found to be very viable for plantations and cash crops like banana, sugarcane, your grapes, which were used for wine production, because these were exported, right? So, but for general farmers, when a lot of more new plants came up, this compost was taken to the general farmers, but for them the price was still found to be very, very high. So that's the challenges of composting. That means the price, subsidization, all these things are very, very challenging, that needs to be looked up. But anyway, some other issues, composting issues. Special equipment is required to deal with mixed waste, reducing yield and increasing production cost. So in case the waste is mixed, as I told you earlier, that we may go for manual sorting, but sometimes it is not adequate. We have to use some mechanical means, and that is where the cost increases, the overall yields reduces, and so on. So that's one of the biggest issues. That means if the waste is mixed, then composting is difficult. Increase in process rejects, thus increasing transportation costs. So of course, if you deal with composting with mixed garbage, In that case, lot of rejects will result in, and that will increase transportation cost. This reject has to be transported to the landfill. So it is double transportation cost. You have to transport compost to the compost plant, then again transport it to the landfill site. Inadequate marketing, inadequate knowledge, and inefficient design of facility. That means each facility of composting has to be designed as per the character of the waste, as per the final product characteristics, and so on. So if you lack inadequate knowledge in the plant design, it will result in a wrong design. Similarly, inadequate marketing means I have to know where I can sell my product or what quality of product. So these are the things which are important. Lack of awareness campaign on long-term benefits. Now, repeated utilization of chemical fertilizers reduces the overall fertility or the condition of the soil. So, what are the benefits of composting? Composting improves the condition of the soil, and repeated application also doesn't create problem. So, this kind of awareness needs to be built up. For that, campaigns needs to be done. Then, additional cost for bagging, transport, and marketing of compost. So, because we have to give commission to the dealers and so on. So usually the final price is twice of the production cost, and usually in 2015 the rate was around 4,000 to 5,000 rupees per ton. Even though some ULBs do subsidize, they sell it at much lower cost. But in general, if I really want to sell compost through a pan-India distribution network, then for a large commercial composting plant, then this would probably be the price that we have to sell it at. So that's why the price is still lot of high, and this also variation due to distance. Like this 1,000 rupees variation is just for different distance of the final end consumer. So coming to the composting feedstock, if it's segregated waste feedstock, that is mostly the municipal wet waste, or which is biodegradable waste, vegetable market waste, yard waste, then there is no problem. But if it is mixed waste feedstock, that is the waste is mixed, then mandatory pre-sorting and segregation of the organic fraction has to be done for composting. Street sweeping waste, drain cleaning waste, these are major sources of contaminants, and this has to be avoided. So this is something which we have to be careful about. If this gets mixed, then the entire compost batch will also get contaminated, and we cannot use that as fertilizer. Now, coming to composting plant overall design, the first area that you have got, it's divided into multiple zones. The first area is the tipping area. So, usually it's a side open large shed. It's a large shed with sides open. This is the area which receives the daily waste, and we have to plan it because composting takes a certain amount of time. So, we have to store waste for a certain amount of time. So that means all the everyday waste comes from the urban area. So we have to have storage capacity for holding waste for that much amount of time. So the quantity has to be really thought of accordingly. The area has to be planned, and unregulated storage is not there. That means we cannot store like someday it is more, someday less, someday we will not store. That kind of operation cannot happen. So everything needs to be planned earlier. Now, the storage area has to have drains because it's organic waste, lot of moisture is there, so leachate would definitely be generated. So this leachate has to be drained via these drains and taken to a leachate collection tank, and finally it has to be treated. Bulky items are removed, like when it's organic garbage, many things like bed mattresses, tire, large pieces of fabric, plastic frame, particularly if it's a mixed waste, all these things are toys, tree branches, all these things remain mixed if it's a mixed waste. In case it's segregated waste, maybe not too much of bulky items are there, but still some remain. So this can be removed in the tipping area itself. So from tipping area, the waste goes to the pre-sorting section. So that is where we prepare the waste before it goes into the windrows or goes into the actual garbage piles where it is composted. So this pre-sorting section is where we remove certain amount of mixed, larger size. Usually it is manual sorting is done. We remove some plastic some plastic bag, or we remove some amount of paper. We remove something like those kind of smaller things, right? So in case this tipping area is also the pre-sorting, then it moves to the pre-sorting area, this particular waste. And sometimes we have, in case of large plants, for example, more than 300 tons per day, then we can increase the size of this holding area by creating a shallow pit. That means that because we create some extra volume below ground. But because we do that, there will be a lot of leachate that will come out. So leachate drainage and daily cleaning of that particular area before we remove that waste to the next area. So all this thing needs to be calculated. And this needs to be also daily, those areas needs to be cleaned. And buffer, usually we have some buffer storage areas as well, areas where there are a lot of these events, festivals, lot of floating population, large gatherings and all. So we need to have some amount of buffer storage areas as well in the plant. Finally, from the pre-sorting section, the compost goes into the compost pad, where actually we create these piles of garbage, which actually is composted. And then this, after the basic composting process is over, we leave the compost for curing. That also requires some area. Usually this area is 1/4 of the area required for the compost pad. So we have got compost pad and there is the curing area as well. So these are the area which is required for setting up a composting operation or a composting plant. Now, composting can be done at multiple scales. It could be a residential composting scale, that means it is done at individual residences. It could be done at a decentralized scale or could be done for the community. Here we can go up to 20 tons. In some countries they may even go for 50 tons as well, but in Indian conditions we can say around 20 tons is adequate. Then there could be centralized large scale composting. In case the value exceeds this, we can go for centralized large scale composting. So coming to bin composting, as you can see in these images, this is in Bobbili, Andhra Pradesh. So this is home composting and done this kind of a container, or you can see like this kind of containers were provided by the ULB in case of Thiruvananthapuram Municipal Corporation, and this is how home composting or residential composting is done. Now, when I talk about decentralized composting, of course, it is a larger scale than this kind of operation, and here we also use different kinds of technologies as well. So I'm going into that. So decentralized composting refers to composting of segregated organic waste in small quantities from households, apartments, neighborhoods, markets, gardens, or even the entire ward. And why we do decentralized composting? Because it will reduce my transportation cost, and we can use the manual labor from informal, waste collectors, rag pickers. Those people could be engaged at the community level. We can create some jobs. And also we can use low cost technologies. We don't have to invest too much into the composting process. So whatever compost is produced locally also could be reused in the local parks and gardens and all. And then, then we don't have to think about selling this compost as well. So this kind of operations are usually taken up at the community level or at the ward level maybe. And this is usually taken up by self-help groups or informal waste workers who come together and they create an operation which is sometimes subsidized, sometimes not subsidized, sometimes it is a profitable operation because recycling also is done along in these particular centers. So some amount of money is also generated by the self-help groups. So the feedstock that comes for this kind of decentralized composting is primarily kitchen waste, which is rich in nitrogen content because we have got fruits, food, vegetables, leftovers and so on. And also yard waste also comes, right? So either it is kitchen waste or yard waste, which is generated in the gardens and all this. Now yard waste has got leaves, twigs, straw, paper and so on, particularly this dry items or brown items, which is rich in carbon content. So this is rich in nitrogen content and this is rich in carbon content. So we have to mix them in a proper way so that we have got proper CN ratios good for composting. So some amount of sorting is required, minimum sorting is required in the pre-processing stage because still, as we said, that even though we sort at the household level, some contaminants remain that need to be removed, and then processing is done via box or bin composting at the community level. So we will learn about what is box composting and bin composting. So these are two techniques of composting which could be adopted at the community level. Now, in this image, you can see those box composting. It's pretty, as the term refers to, these are boxes. Either it could be a series of boxes like over here, or it could be individual boxes, as you can see in this image. And here, the these are bin compost. These are bins, right? So the first we talk about bin composting. So the bin size is determined as per the quantity of waste is generated at that particular community or that particular ward. And the bins, as you can see, is designed like this. The walls are perforated so that it allows air to mix. So it's an aerobic process. And 15 centimeter thick drainage layer at the bottom. This is prepared using twigs, stones, and mulch. Mulch is like made of organic matter like trees, leaves, and all these things, which is not composted, but it gradually decomposes to a certain extent. But we call them mulch because it takes a long time to decompose as well. We sometimes spread this in the gardens and all. Instead of making compost, we just spread those leaves all around, and automatically eventually they will mix with the soil. So this kind of material is usually laid at the bottom, so it acts as the drainage layer which allows the leachate to pass through, and the leachate is of course collected. Organic waste is placed above this in layers, and usually the feedstock is mix of garden or yard waste, kitchen waste, dried leaves, and paper. Moisture is also provided, but it should be adequate, not excess, because excess moisture will lead to excess leachate production. If we find the moisture is too much in the waste, then we can add dry leaves, twigs, and paper, which will reduce the moisture content. Finally, at the top, we provide a compost layer, which not only provides insulation at the top, but also prevents odor and acts as an inoculum, which starts the this composting process. And every 5 to 10 days, we turn it regularly to prevent anaerobic conditions and also adequate sanitization of the entire mass. So that means entire heat is produced so that the overall compost is sanitized. So the total time taken could be from 45 days to 6 months as per the turning schedule and the waste characteristics. So that means as per the waste characteristics or how much often we turn it, it may take from 45 days to even 6 months for the organic matter to convert into compost using bin composting. Then we come to box composting. It's similar to a bin composting but with some changes. As you can see in this particular image, this is the structure. The floor is sloped so that the leachate is collected in the drains, and the bottom of this looks like this. So here either I can have a base which is perforated for the moisture to come out, or I can create the base with a some pipes, so that automatically there are gaps between the pipes like over here, and the moisture can come out. And inside also the walls are also perforated. Like in the previous image we saw the walls have been, gaps have been left in the wall. Here it's a brick wall because it's a larger in size. It's a 3 to 5 ton compost box. Here also some gaps in the bricks are kept so that moisture, air can actually go through, right? And in between the compost also we keep some perforated pipes which actually takes the oxygen inside and also helps in release of the gases as well. So space requirement is less than standard windrow composting. We will learn about windrow composting in the next lecture, but windrow composting is basically where we pile the garbage in large heaps in a garbage pad or a compost pad. So it is less than that. Slope is provided at the base. The base is perforated or PVC metal pipe network, which facilitates aeration and drainage. And then perforated PVC pipes are also placed vertically, as we just discussed. So pre-sorted organic waste is spread in 20 centimeter layers, one after another. And when one layer is added, this layer comes after certain days, new waste, after each day new waste comes in, and it is laid out in layers one above another. And whenever one layer of waste is added, we loosely mix it with the former layer we disturb the upper layer of that waste and we mix it so that the bacteria that is there in the bottom layer will also move up to the upper layer as well. So usually if you say that if 3 tons of waste is generated per day, then it takes about 5 to 6 days to fill this kind of a box. Temperature and moisture is frequently monitored. in this particular boxes, and if we find the compost is dry, then we have to add moisture. And sometimes if we see the moisture is too much or we see the compost is compacted, to allow passive aeration, we mix straws and other kinds of dry matter so that there is gaps inside the compost and air can pass through. So after 40 days, it takes roughly around 40 days for the compost to be ready, which is a little bit lower than the last one in case of bin composting. And after then we screen the compost, and initial compost, the compost that is produced initially is coarse, as we have discussed. Is coarse. So we need to put it through a screen. So the larger particles are taken to some may be taken to a RDF plant, right? So or the smaller particles can be again used as screen for the we can put it as cover, as insulation for the other compost. And this screening process results in the finer compost, and this could be achieved by a flat frame or a rotating drum sieve. And this screening process actually prepares the compost for the next stage, which is curing, or maybe some amount of screening could be done even after curing, and after that the compost is ready to go to the market. So over here you can see box composting happening in Keonjhar municipality. Over here you can see the boxes. There are some pipes. These are the pipes which are for aeration, and this kind of, and also some conveyor belt segregation of biodegradable waste. So some amount of segregation, mechanical segregation is being done using conveyor belts over here, and the garbage is taken along the belt and some amount of segregation could be done. And finally, this is a micro composting center, and the organic manure that is produced over here is branded as Mo Khata and sold at rupees 20 per kilograms at outlets throughout this particular state. So that is how composting, this micro composting center is operated at Keonjhar municipality. Then in Vijayawada Municipal Corporation, around 198 tons of organic waste is processed for composting in 4 decentralized waste to compost plants. So this is one of the plants you can see in the image. Biodegradable waste comes here, it is put inside a shredder, so it is shredded into smaller particles over here. Then these particles are put inside the boxes where it is composted. So this is box composting also happening in Vijayawada Municipal Corporation. Then coming to centralized large scale composting, this is where plant sizes can reach around even 500 tons per day. That means 500 tons per waste comes per day. So definitely we have to do a proper analysis of the location of the plant, or the design of the plant has to be thought of properly. So technical and environmental assessment of potential sites has to be done, like we have learnt about this analysis for site for a landfill. We will learn about that, or similarly we can also do analysis for potential site for a composting site as well. Use of engineering and design professionals for the facility design, it has to be designed following particular procedures. We have to minimize traffic, odor, leachate and noise from composting operations, because it's a large plant. It has to be set up in an industrial area, so it cannot be set up like in the normal residential areas, and we have to minimize all this. Separate collection and pre-processing system involving informal sector, so we can do pre-sorting involving informal sector. And we have to recover non-compostable materials. Some can go to RDF and some can go to as process rejects to the landfill site as well. Protocols for quality and composition of compostable materials, design of routes of the delivery of the organic material, and marketing strategy for compost. So all this needs to be worked out for a centralized large scale plant. Why? Because this requires a lot of investment. So if for doing proper investment, because a lot of money is involved, we have to do proper analysis for which locations are suitable, so that later on there are no protests. What should be the proper design so that the resulting compost is of proper quality. We have to also do marketing strategy for the compost that is being produced, and also design routes and all for distribution of this compost, so that overall the system is successful and there is no loss of demand after a certain amount of time. So we do a case study of Mysore Municipal Corporation, which does both decentralized and centralized composting. So segregated waste is collected in Mysore and this is being composted. Mixed waste is also there in some parts, which is not sent to the decentralized plants but goes to the centralized unit. And also non-biodegradable waste is collected in Mysore, which goes to 43 collection centers. So this is where the waste gets segregated and recycling takes place. So but for wet waste, we have this both a centralized plant as well as decentralized plants. So the centralized compost unit is located at the outside the city, whereas 9 decentralized zero waste management units, that is what they call them, or compost plants, is located inside the city, and one for every 5 wards. So that means one plant has been created for every 5 wards. So over here you can see a windrow that is in the centralized compost plant in Mysore. This is how the windrows has been created. That is how the garbage has been stacked, and this is left for a certain amount of period. Then it is turned as well. How do we turn it and all this? We will learn that in the next lecture. But this kind of windrows are being utilized, and compost is done through piling waste in long rows, which is known as windrows, and aeration by turning periodically. So we turn the garbage after certain intervals. Then once the garbage becomes compost, 2-stage screening is done. Final compost, because of the screening, becomes uniform in texture, and 50 kg bags are being prepared and sold at ₹1,200 per ton. So some amount of, the cost is not that high. It is sold to nearby farmers, and this operation is done by a private company, of course, and some amount of this compost is used by the horticulture department of the city for application in the urban areas. So the plant is located at Narayanpur, Puram, Mysuru, and capacity is 200 tons per day. Vidyaranyapuram, mechanized aerobic windrow composting. So it's aerobic windrow composting, and the turning is done by a mechanized processes. We will learn in details later. The corporation owns the land, the infrastructure and the machinery that is being utilized, whereas the operation and maintenance is done by ILFS, which is a private infrastructure company. The overall model is a PPP model, where both the government and the private company works together. ILFS pays land rent and royalty to MCC. So that means they pay some amount of money for utilizing this particular area as well as royalty for production of compost. So the profit they make by selling compost is what the company keeps. But they will pay around 6 lakhs rupees per annum to the corporation, so that they can, as a royalty or as a token amount, so that this operation can happen. 5% of the compost that is being produced is also given back to MCC, which MCC utilizes, the horticulture department of MCC utilizes for their in the urban parks and gardens and so on. Now this is the centralized plant, whereas in the decentralized or zero waste management unit, the composting happens via peat composting. So that means the compost is done in sort of a chamber, it's a pit, and vermicomposting also is utilized. We will learn about again vermicomposting process later on, where we use earthworms for the composting. Area of each of this is around 1.5 to 4 acres. So this sort of areas needs to be also put in development plans, so that we reserve this kind of areas in development plans for this kind of composting operations. Capacity of these plants are around 5 tons per day. So each of this decentralized unit have got a shed which receives, segregates, processes and stores the waste that is received. This is managed by NGOs, self-help groups, or Stree Shakti Sangha, where women are being empowered to run this kind of operations. MCC infrastructure, vehicle and financial support is given by MCC, and they pay around 95,000 rupees per month. Revenue coming out of this, which is kept for the self-help groups or the people who are working there, which comes to around 15,000 to 30,000 rupees per month. So that is by selling the compost. So this is what it looks like. So decentralized operation is actually not profitable, but because it's decentralized, we save on transportation cost, we save on, this particular compost could be utilized locally and so on. So there are a lot of environmental benefits as well. But in centralized plant, there is of course profit by selling of compost. Then coming to the final product quality or the compost quality, and because compost is used in food crop production, it could be used in soil conditioner. Some special compost could be produced like phosphate-rich organic manure, PROM, which we discussed earlier. Then vermicompost is also there, right? Vermicompost is compost via earthworms. So each of them has got certain standards, and the standards are usually prepared by fertilizer control order, FCO. This is by the fertilizer departments of the government, and there are 2009 standards, and so FCO has given this in 2009 they have given these standards for organic fertilizer. Similarly, Software Management Rules 2060 has also given us certain standards for compost, which could be used as soil conditioners in the urban area. Then PROM has got certain standards, and similarly vermicomposting has also got some other standards. Now, what are the standards and all? I will come to that. So, municipal solid waste is segregated at source, but still contains glass, plastic, metals and hazardous materials, which contaminates the finished product. This we have learnt earlier. And so that means we have to make sure that the final compost is of proper quality. This kind of contaminants are not there. That's why we have created this kind of standards, so that we can check against those standards if the compost is of adequate quality or not. Then compost quality should ensure no leaching or plant uptake of heavy metals and prevention of the accumulation of heavy metals even after repeated application. So what does that mean? That means compost should not have heavy metals, or it should have heavy metals as per the standards. The heavy metal should be such, the standard value should be such that even after leaching or uptake of the nutrients by the compost, and even after repeated application of the compost yearly, that means over a period of years, the total concentration of heavy metals will gradually increase, but overall the plant, we should not have this concentration of heavy metals which should be harmful for human health. So the initial standards has to be set considering all this, right? So that is why we have to be very careful while setting standards for compost. And why? Because this is municipal waste we are talking about, and municipal waste contains batteries which contains heavy metals such as mercury, cadmium, lead, zinc, leather which includes chromium, paints chromium, lead, cadmium, plastics includes cadmium, nickel, light bulbs has got lead, paper has got lead, consumer electronics has got lead and cadmium, ceramics has got lead and cadmium, cosmetics, dust from sweeping. So all this includes a lot of heavy metal. So this heavy metal should not come into the agricultural fields. So that is our goal. And because we are dealing with urban city compost, this we have to be very, very careful about. That is where all these standards come into place. So we have got heavy metal standards. These standards also needs to be re-evaluated after certain time periods. That means after maybe 5 or 10 years, the standards needs to be revised as per the health concerns or of that particular community or that particular society, right? So standards can be improved upon. Like earlier the standards were poor, but the more we progress, the standards are set higher and higher so that the final product is better and better. Then we have got pathogen standards, that what sort of pathogens are allowed at the end. That means composting is a process where there are microorganisms and then there are pathogens. So at the end there should not be any pathogens left in the compost, right? Then nutrient standards, what should be the contents of the micro and macronutrients so that it is beneficial for as a fertilizer. So those standards also has to be maintained. So carbon, nitrogen, phosphorus, potassium, trace amounts of sulfur, sodium, calcium, magnesium and iron. These are the different nutrients that we are talking about. So this sort of 3 standards has to be there. That means it may be one set of standards for the compost, but actually we have to look into these 3 sort of items that should be, or 3 groups of items that should be considered while we set a compost standard. Now compost should also have a desired carbon to nitrogen ratio. Usually this value is 25:1 for carbon to nitrogen, and carbon is used by microorganisms for energy and growth, so there has to be adequate carbon in the organic waste, otherwise the process will not happen properly. And nitrogen is required as protein and for reproduction, because you need to create more microorganisms, so you require protein, so nitrogen is required for reproduction of the microorganisms. So ideal ratio is 25:1, but if it is lesser than that, then it will result in foul odor. That means carbon value is less and somehow it results in more odor, and the process takes longer time and so on, and also some anaerobic process starts happening. So in India, we usually find the CN ratio is around 30:1, which is suitable for decomposition. So it's suitable, of course, is 25:1, but even 30:1 is fine. So in case the CN ratio is not proper, that means we get a sort of waste where there is a lot of food waste, but there is no nitrogen, no carbon in it. So in that case, I have to mix materials which will bring in more carbon. So that means we have to combine various kinds of organic waste to reach the desired CN ratio before we start the composting process. So leaves, straw, which are high in carbon but low in nitrogen, can be blended with food waste which is high in nitrogen to balance the CN ratio. Rate of decomposition declines when CN ratio is above ranges, and nitrogen is usually lost beyond 30:1, and organic matter having high nitrogen content could be added in that particular case. Now sometimes slaughterhouse waste is also added in the composting, but in that case we require special composting systems such as closed systems or in-vehicle composting system to actually deal with slaughterhouse waste. So now coming to the compost quality, this compost quality standards are set as per the Solid Waste Management Rules, Fertilizer Control Order 2009, 2013, and then there is the Vermicompost Standard, again which has been created in 2009. So as you can see, the first group are the heavy metals, arsenic, cadmium, chromium. So these standards are same for both PROM as well as FCO. Then there is the CN ratio, pH, moisture, bulk density. These are the characteristics of the compost. So that values are given. CN ratio should be around 20:1, less than 20:1, final CN ratio. Then pH is 6.5 to 7.5. Moisture is around 15 to 25%. The final, the content, the compost that how it should have. Bulk density is lesser than 1. This is percentage of weight, and so on. Similarly, for particle sizes, all particles should pass through a sieve of 4 mm size. All means 90% of the material should pass through. So that means the compost should be of so small that it should pass through a 4 mm size. There should be no foul odor, and the color should be dark brown to black. So these are the characteristics that has been set. So we have to check the final compost against these characteristics, and if we are compliant, then the compost is fine for use. So these are some of the references you can use. And to conclude, composting is practiced at different scales: residential scale, decentralized community scale, or centralized urban scale. Non-compliance of compost quality standards makes the entire process unfeasible. So that means we should be careful that when we design our processes in the centralized plant or decentralized plant, we have to make sure the final compost quality should be as per the quality standards set. Thank you.